Hello all and welcome as we continue our work on polynomial equations. Today's exercise 6D, as it says there, is solving polynomial equations. So today we're pulling together all our skills that we've taken so far in this topic and also previous topics. So all our skills, especially surrounding quadratics, will become really important in this exercise, because when we start factorizing down quartics and cubics, one of the factors almost always ends up turning into a quadratic, and then we need to use our quadratic skills to help with those. We also, because we're actually solving, when we see the word solving, that means we're not only factorizing, but we're actually trying to solve for a certain variable. We're trying to figure out what something is, and almost always in these cases we are solving for x. The other thing to note with this is that all these skills and these tools, especially the Null Factor Law, revolve around these polynomial equations being equal to 0. They actually have to be. We can't apply the Null Factor Law if the equation doesn't equal 0. So if it doesn't equal 0, you need to rearrange it so it does equal 0. Then you can start applying all the skills. So as a bit of a warm-up, here are 4 quadratics for you to have a go at to factorize. I suggest maybe first trying inspection, and then from there work through that workflow of, if you can't do inspection, try completing the square or use the quadratic formula. So maybe pause the video now, and I'll go through the solutions. So we need, using inspection, 2 numbers that multiply to give me 4, and the same 2 numbers need to add to give me -5 as a reminder. So 4, that would be -1 and -4 multiply to give me 4, add together give me -5. From there, using the Null Factor Law, we can say x minus 1 is equal to 0, and we can put a comma there instead of having to write the word or in this case x minus 4 could also equal 0, or has to. It's one or the other, has to be true. So we get from that x is equal to 1 or x is equal to 4. Same thing for example B. We need 2 numbers that multiply to give me 45 and add to give me 14. So 45, 9 and 5. 9 plus 5 is 14, so that works. So x plus 9, x plus 14, not 14, x plus 5. From there, again, using the Null Factor Law, we can say x plus 9 is equal to 0, or x plus 5 has to be equal to 0. We get x is equal to -9 and x is equal to -5. We'll see similar sort of thing. Hopefully you're starting to remember this, and this is one of those reasons why we did this as one of those homework battery sheets, is to build these skills. This happens to be +2 + 2. So this was repeated, so we just get to say x plus 2 is equal to 0. We could technically also say x plus 2 needs to be equal to 0, but since it's repeated, we don't need to write it a second time. We just get x plus 2 has to be 0, so x is equal to -2. So there's only one solution for that one, because it's what's called, if you remember, this, when we have the same factor repeated, that's called a repeated root. Rightio, this fourth one, x squared plus x plus 11 is equal to 0. Now 11 is a prime number, so the only way to make that is 1 times 11. Now there's no way I can turn 1 plus 11 into a single 1 there for that x, so this straight away screams I can't do it with inspection. I need to either do it completing the square or use the quadratic formula. I'm going to check what the discriminant is equal to. So just as a reminder, that is equal to b squared minus 4ac. Because if the discriminant's less than 0, we know there's no solution, so we could stop there and stop wasting our time trying to do complete the square. But I get b squared is 1 squared minus 4 by 1 by 11, so I get 1 take away 44, so I get -43. So we can see there is actually no, and I should say no real solution. Rightio, so we've done all of those solving. So part of the skill was, and when we solved, the general train is, and for quadratics we've learnt, we first need to factorise. That's our step one, however we want to factorise. And then step two is apply the null factor law. Okay? So that's for quadratics. Now, for something bigger than a quadratic, we have to put in a step here, is that we have to apply, or it's still actually part of factorise, but we'll have to repeat this step multiple times to try and get all the factors. Be it the very first step, you might have to use the factor theorem to find a factor, then use that factor to do long division. Then once you have long division, you'll have one factor and say quadratic, then you can apply the regular quadratic skills, but we'll have a look through that. So applying the null factor law, solve the following for x. So this is already factorized for us, so straight away we can say x minus 2 is equal to 0, or x plus 4 is equal to 0, so we get x is equal to 2, x is equal to negative 4. Over here, just quickly note there is a square here, which if we wanted to write this expanded out would be x minus 3, x plus 1, x plus 1 again. So it's just a repeated root, but same thing, we get x minus 3 is equal to 0, or x plus 1 is equal to 0, so we get x is equal to 3, or x is equal to negative 1. And lastly, we have that, and x minus 4 equal to 0. So the null factor law can be applied to things greater for more than two factors. It's the same thing. We have a times by b times by c, each one of those brackets is one of those things, and equal to 0. It's very clear that either a or b or c has to be equal to 0. So we could have as many factors as we want. We could have 7 factors, but if they all multiply to give me 0, one of those factors must be 0. So we get x is equal to 1, x is equal to negative 2, x is equal to 4. Rightio, so let's now tie in our skills that we've learnt in the rest of chapter 6. So pretty much everything so far should be revision and review. Now we're going to bring in skills. So divide x cubed plus 2x squared minus x minus 2 by one of its factors. So we're told it's a factor. So that means the remainder should be equal to 0 of x minus 1. And then write in the form of the polynomial is equal to divisor times by the quotient. And you can see there's no plus x here because there's no remainder because it should be a factor. So you can do this division using either equating coefficients or by using long division. I'm going to do long division just because it's something that I think pretty much everyone always needs to practice, and let's give myself a little bit more space. X minus 1, here we go, x cubed plus 2 minus x minus 2. Okay, so our x is our main one there, so we're going to do x cubed divided by x gives me x squared. I multiply that by everything out the front, so x cubed times by x squared is, x squared times by x is x cubed, x squared times by, so I'm doing this, x squared times by negative 1 is negative x squared. Apply the subtraction now, so I get 0, 2x squared, take away negative, so that becomes 3x squared, take away x, take away 2, and then I just repeat the process again. So 3x squared divided by the x leaves me with plus 3x. Now I'm going to do multiplication by everything at the front, so I get 3x squared minus 3x. Apply the subtraction, get 0 again, negative x take away negative 3x, so that's going to be adding 3x, so that becomes 2x minus 2, and do 2x divided by our x out the front, that leaves me with plus 2, 2 multiplied by everything out the front is 2x minus 2, and apply the subtraction, and I get 0 and 0, so remainder is 0, so that works. So therefore, p of x is equal to, now what we're dividing by, that is the factor. So we get x minus 1, and then my result here, that is my what's called the quotient, or the answer, is x squared plus 3x plus 2. And so we're done. We're done. Now, as per this question is, but to build those skills, what would be the next steps if we were asked to, like here, fully solve? Maybe we were told that this whole equation is equal to 0. What do we go from here? Well, the next step is we would want to then just factorize this quadratic. So we could factorize this down to x plus 2, x plus 1, and then if that whole polynomial was equal to 0, we could then apply the null factor law. And oh, my dog's just come back from the vet, and she's very happy to see me. Where'd you go? There we go. Okay, down, Gracie. So that's what we would do. That's why we have all those quadratic skills, because when we start factorizing a polynomial of higher order than 2, we're going to at some stage get this quadratic. Right, so last example. By first finding a factor, solve the equation blah. So solve, what does this imply? Or by finding the factor, let's think about what that first bit of the question implies. Well, that means we need to use the factor theorem from 6C, and then once we've used that to find one factor, we're going to follow the same process from this previous example where we are going to factorize, I guess completely would be something that we could say, so that it's completely linear factors. So we want to end up getting it written as a set of brackets like that, where it has something, something, something. So we first need to find a factor, then we need to take that out either by long division or equating coefficients, then from there we need to factorize the rest of the way. So that's the process I'm now going to go through. So find a factor. Well, we need to look at the constant at the end, so that means I can use plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So there are heaps to go at. Again, because all those numbers are factors of 12, there is a negative in here, so that means a positive factor could work. Because remember from last video, if these were all positive, well then it's obvious that x needs to be negative to make that whole thing equal to 0. So I'm just going to straight away just do plus or minus 1. So p of 1 is equal to 1 minus 6 plus 5 plus 12. That does not equal 0, so that's no good. P of negative 1 is equal to negative 1 minus 6 minus 5 plus 12, and that is equal to 0. So there we go. So from that, what we do is we let x equal negative 1. We need to rearrange that so it's all equal to 0, so we get x plus 1 is equal to 0. Therefore, this is our factor. Okay, that's using the remainder and factor theorems together. We've now found our first factor. So from there, again, you can use equating coefficients or long division. Maybe because we did long division on the previous one, I'll do this equating coefficients. So it is obvious, okay, by looking at this, that p of x must be equal to, and we figured out x plus 1. Now, if we took that x plus 1 out, what is the rest of this polynomial going to be? Well, the highest order, it's a cubic. So to build that cubic, this would need to be a squared term, because that x times by x squared gives me this x cubed, plus bx plus c. Now I'm not going to put in the a because it's very obvious that, well, x times by x squared gives me x cubed, so a is automatically going to be 1. So I can take that little bit of a shortcut. Now I'm going to start expanding all of that, so I get x cubed plus bx squared plus cx plus x squared plus bx plus c. I'm going to group like terms, so I get x cubed plus bx squared plus x squared. So I've grouped that and that. I'm going to group the cx and the bx. So I get plus cx plus bx and then plus c on the end. Let's start to do a mini factorization inside that. B plus 1 x squared plus c plus b x plus c. Now we can equate coefficients. And that's the whole point of doing this process, is to be able to equate coefficients. This b plus 1 must be that negative 6. This c plus b must be this 5. And this c must be obviously this 12. So by equating coefficients straight away, we can see c is equal to 12. What do I want? C plus b is equal to 5, so I get 12 plus b is equal to 5, so b is equal to, take 12 from 5 is negative 7, and we can do a check on our final bit, which said b plus 1 is equal to negative 6, and if I put negative 7 plus 1 is equal to negative 6, so negative 6 is equal to negative 6. So that works. So we've found C and B, and we already knew A was 1. So I can write now, and I'm going to come back over to the left, over here, just to leave a little bit of space. We've now got P of X is equal to, we fill it in, X plus 1, bracket, x squared minus 7x plus 12. Now I've got that quadratic. Finally, I can apply any of my quadratic skills to try and factorize it. I'm going to try and do that using inspection. So two numbers multiplied to give me 12 and add to give me negative 7. That's going to be x minus 3, x minus 4. Now that's fully factorized. And we're fully factorized down into this linear form. It's written as a product of all linear factors. Now it's written as a product of all linear factors using the Null Factor Law, because we were told this original polynomial was equal to 0. That's the only time we can use the Null Factor Law. It's quite obvious that x plus 1 is equal to 0, or x minus 3 is equal to 0, or x minus 4 is equal to 0. So we get x is equal to negative 1, x is equal to 3, x is equal to 4. And that's it. Again, you could have done this, the whole bit on this right hand side. You could have done that whole bit instead using long division. On the test, just to make sure you have both skills, because sometimes problems are going to lean themselves towards being more efficient to do by equating coefficients. Sometimes it'll be better to do it by doing long division. You want to have both skills down pat, and in the test it will ask you to do both of them at some stage. But questions where it's open like this, where it doesn't give you a method, you can use either one that you want. But there will be at least one question asking you to do each on the test, so practice both. That's it. If you have any questions, feel free to ask in class or put a comment below or send an email or put in Google Classroom. Have a good day.